But sometimes I am being late in other classes also.
वाह, बहुत अच्छा कर रही हैं आप, सब क्लास में लेट हो रही हैं। हाँ, वेरी नाइस। मतलब शी इज लाइक, लेकिन ठीक कीजिए, ऐसे नहीं चलेगा ज्यादा दिन, है ना। वी डिड टिल स्टीफेंस रिएक्शन, राइट? स्टीफेंस तक किया था ना हम लोगों ने, स्टीफेंस
Yes,
तक
sir.
किया। चलिए, राइट, नेक्स्ट, यूजिंग डिबाल एच, दिस इज द थर्ड। अच्छा, हाउ मेनी पेजेस? आप अपनी दोस्त से पूछ लीजिए सारा पार्कर से कितना पेजेस छोड़ना चाहिए। वेरी प्रेजेंट, और अच्छा आप एक, अच्छा अभी तो एक ही क्लास हुई है ना, हाँ ठीक है। एल्डिहाइड कीटोन्स में एक ही क्लास हुई है, तो सारा पार्कर, हाउ मेनी पेजेस शुड योर फ्रेंड लीव फॉर एल्डिहाइड कीटोन्स एंड कार्बोक्सिलिक एसिड?
3 pages.
3 pages, ठीक है फातिमा, लीव 3 pages and then write. The third method of preparation for aldehydes only is using Dibal H, diisobutyl aluminium hydride. Right, next, nitrides and esters can be reduced with mild reducing agent such as diisobutyl aluminium hydride. Such as diisobutyl aluminium hydride to imines first, and on further hydrolysis it gives aldehyde. So what is diisobutyl aluminium hydride? It is aluminium then it has butyl. What is butyl? Butyl is this one carbon, two carbon, three and four carbon. First carbon, second carbon, third carbon, and fourth carbon, and one hydrogen. So you have diisobutyl. This group is butyl, and specifically it is isobutyl, and then you have hydride. This is the structure of Dibal H. And what does it do? It reduces nitrides RCN to, first of all, imine. Imine is again the same thing, R, CH double bond NH, and then it further reduces it to, on hydrolysis, to RCHO. If you have something like this, and also if you have esters such as double bond O, OCH3, Dibal H, second water, then 1, 2, 3, 4 carbon atoms till the carbonyl compound you're going to write. Okay, The carbonyl carbon you're going to write, and then you just write hydrogen, CH. So Dibal H, if you even have a double bond, it does not disturb the double bond, and it will give you aldehyde. Right, next, Etard reaction. Please write alkyl benzenes can be oxidized to benzaldehyde with a solution of chromyl chloride in non-polar solvents such as CCl4 carbon tetrachloride or CS2 carbon disulfide. A brown, yes, Samia, we started aldehyde ketones and carboxylic acid. A brown chromium. अच्छा, एक बच्चा था ना जिसको फ्राइडे का कुछ पता नहीं चला था. Samia, was that you?
No, sir. I got the link, but I was in Medina, sir.
Okay, you were in Medina. Okay. Samiha, I think that was you. You
Yes,
did not receive.
I didn't get the link. Yeah.
Okay, ठीक है. I will. हम एक सेकंड जिस तरह बोल देते हैं. A brown chromium complex is formed, which is decomposed by water to give benzaldehyde. So you have some alkyl benzene. Let's suppose CH3. First step is chromium chloride, which is chromyl chloride, which is CrO2 Cl2 in the presence of CS2. This CS2 is not a reagent, it is just a solvent. Please remember that. And it gives a brown colored complex which has a formula CHOCrCl2 OH whole twice. On the hydrolysis, that means addition of H3O plus, this gives benzaldehyde. Okay, if you have alkyl benzene with more than one carbon atom, such as CH2, CH3, in the first step, we have CrO2Cl2. See, I'm not writing CS2, that doesn't matter, okay, because it is just a solvent. Reagent is chromyl chloride. Second step, H3O plus, and it is going to give me CHO in the terminal carbon. So you'll have CH2 as it is. After that, this CH3 will get converted to CHO. And we put water in the second step, because if you add H3O plus in the presence of chromyl chloride, it is going to get converted into a strong oxidizing agent, which will give you carboxylic acid, not aldehyde. Okay? So we use non-polar solvents such as CCl4 and CS2. Right, this one is what, fourth, right? Fifth one. Using chromic oxide.
Sir, can you go up 1 second? Okay, sir.
In acetic anhydride. Please write with me. Treatment of alkyl benzene. With chromic oxide in the presence of acetic anhydride gives aromatic aldehyde. So again, we have alkyl benzene such as methyl benzene here. Here we are going to use CrO3 and CH3CO, hold twice and then oxygen. And we do this in a very low temperature from 0 to 5 degrees Celsius. That is 273 Kelvin. 10 तक भी जा सकता है, I think 283 Kelvin. ठीक है, between 0 to 10 degrees Celsius. And then we get CH OCOCH3 OCOCH3 hold twice. And when we do hydrolysis, it is going to give me CHO plus 2 carboxylic acid. Write the name of the structure. This is benzalidene. Benzalidene diacetate. Right, next. See this CH3CO, ये क्या? I mean, if you don't know the structure, this is acetic anhydride. Okay, I hope you have seen this structure before also. This is CH3, C double bond O. Okay, CH3, C double bond O twice, and then you have oxygen in between them. Right, the sixth method of preparation of aldehydes only by using side chain chlorination. Once again, alkyl benzene, CH3, in the presence of chlorine and light, that is H nu. What is going to happen? This hydrogen is going to get replaced by chlorine. And you know that this does not stop by one replacement. This substitution can happen more than one time. So it will be CHCl2. After CHCl2, what is going to happen? You add water at high temperature, 373 Kelvin. And then you are going to get these two chlorines will be replaced by OH. So you'll have CH and you'll have OH here and you'll have OH here. Now this is a case of gem diol. Gem diol means you have ol group, hydroxyl group in the same carbon atom. Whenever you have gem diol, it gets converted to aldehyde. Water leaves like this and you get aldehyde, CHO. Okay, this is gem. This structure is not gem diol, but this fragment yahan pe. Okay, this fragment is gem diol. Done, everyone?
No, sir.
लिख आराम से लिखिए सर. अब तो लिख लिया होगा.
Yes, sir.
Okay. Right, next. Again, a name reaction. This is the last and the seventh method of preparation. Gatterman-Koch reaction. सबसे पहले you will draw something which looks like the entry point of a gutter, है ना? The gutter lids are like this only. Okay. Plus you have Koch, KO to CO, and then you have CH का उल्टा HCl. In the presence of anhydrous AlCl3, you are going to get benzaldehyde. Please write when benzene is treated with carbon monoxide and HCl in the presence of anhydrous AlCl3, it gives benzaldehyde. Done, everyone? Can I move on?
Yes, sir.
No, right. C part. Method of preparation of ketones only. Right, number 1. From acyl chlorides. Please write. When acyl chlorides are treated with, when acyl chlorides are treated with dialkyl cadmium, in the presence of dry ether, they form ketones. Right, next. Dialkyl cadmium is prepared by Grignard reagent and anhydrous cadmium chloride, CdCl2. Look at the reaction. You start with a Grignard reagent, RMgX, and you treat this with cadmium chloride, Cl2. Now here R is negative, delta negative, because it is bonded with magnesium, which is a metal. Metal has a tendency to lose electron. That is why it is losing electron towards the alkyl group. And alkyl group is getting delta negative. Here cadmium is going to have 2 positive charge. So the alkyl group will attack on cadmium and it will displace the chlorine atom from here. So you are going to get here CdR twice. Instead of chlorine, what has happened? Chlorine has been displaced by R. Plus you get 2 moles of Mg, whatever X was used, and Cl. Then we take the acyl chloride. You have R dash, C double bond O, some other alkyl group. And you take 2 moles of acyl chloride. You react this with R2CD. Okay, dialkyl cadmium. Now the same thing happens here. This R group now is going to displace this chlorine here. Okay, now it is going to displace that chlorine, and you are going to get 2 moles of R dash, C double bond O, and some other R group that is making a ketone. Plus you will get the CdCl2 as it is. Okay, for a specific example, please write. We have 1,2 carbon, and then you have MgBr. Plus you have CdCl2. This will give you cadmium, you will get the alkyl group, 2 carbon atoms. See, you will get the 2 carbon atoms on cadmium like this. Okay, you have the 2 alkyl groups here. Now, plus you are going to get MgBrCl. ठीक है. Now this alkyl दिख रहा है कि नहीं दिख रहा है आप लोगों को? ऐसे लिख लीजिए अगर नहीं दिख रहा तो. You have cadmium and you have CH2 CH3 whole twice. Now you have this 2, ठीक है, dialkyl cadmium plus you take some R dash C double bond O Cl. Then what? Okay, नहीं, R dash मत लिखिए, CH3 लिख लीजिए. Specific example CH3. What is going to happen? This alkyl group is going to attack onto this carbon, displacing this chlorine. So you'll get CH3, C double bond O. Here you will get 1 carbon and the other carbon here. So 2 carbon. Please remember, here you had 2 carbons. Okay, the same 2 carbon is here. First, you have the carbons in the Grignard reagent. They get transferred to the cadmium. Then from cadmium, it gets transferred to the acyl chloride, leading to the formation of a ketone. Okay, so this is coming from CdR twice, which this R is coming from RMgX. Okay, please remember this. Can you write this down? Let me know once you're done.
So can you scroll down just 1 minute? Yeah, okay, thank you.
Is everyone done?
Yes, sir.
Okay, sabne. Anyone still writing? No. Right, next. From nitriles using Grignard reagent. Is right. Both aliphatic and aromatic ketones can be prepared by treating an alkyne or aryl nitrile with suitable Grignard reagent. Followed by hydrolysis. So see, in this reaction, I start with the Grignard reagent, CH3, CH2, MgBr, and we take a nitride, CH3, C triple bond, N. Now this N is more electronegative, that is why it is going to pull the electron from carbon atom, making this carbon delta positive. Now this carbon is attached to magnesium, which is an electron donating group because it is going to be a metal element and metal loses electron. So this will get delta negative. Now this carbon atom is going to attack on this carbon atom. And one pi bond is going to break like this. So first of all, we are going to get the CH3CN you will draw. CH3C double bond N because one of the pi bond has broken. And what bond has been added? These two carbons have been added. What are these two carbons? You have CH2, CH3. Okay, CH2, CH3. And then this nitrogen is also bonded to MgBr. Now, after hydrolysis, this nitrogen, it is going to be displaced by this oxygen atom, and you are going to get CH3 carbon, and below you have CH2, which is bonded to CH3, and here you have double bond O. Okay, so see these two carbon atoms are coming from the nitride. The other two carbon atoms are coming from Grignard reagent. This oxygen is coming from water molecule. Okay, please write this down. We'll get some byproducts such as NH3 plus MgOHBr. Similar reaction happens even if you use an aromatic Grignard reagent, and you have ऐसे कर लेते हैं इसको. In the first step, you have 3 carbon atoms. Please remember, okay? 1, 2, and 3 carbon atoms. Second step, you have S3O plus. So you'll get the benzene ring as it is. Then you will have first carbon atom, second carbon atom, third carbon atom, and this carbon atom is going to get the double bond. The carbon on which the benzene ring is attached, or the carbon on which we are attaching the alkyl group from Grignard reagent. Okay. So wherever you have the bond between nitrile and Grignard reagent, so nitrile wale carbon mein you will add double bond. Write this down. Done, guys? Yes or no?
1 second.
1 second. Okay.
Done, sir.
Write the third. Friedel-Crafts acylation of benzene. Right here. Aromatic ketones can be prepared by treating aromatic hydrocarbons with acid chloride. in the presence of anhydrous AlCl3. Benzene ring plus acyl chloride of 2 carbon atoms. Okay. So when you have 2 carbon atoms, then anhydrous AlCl3, this will be attached on benzene ring. C double bond of CH3. If you have more, same anhydrous AlCl3, you get 1, 2, 3 carbon atoms, 1 atom, 2 and 3 carbon atoms, double bond O. If you have a benzene ring plus you have another benzene ring with C double bond O Cl, then also what is going to happen? You'll have benzene ring, then this carbon atom that is containing double bond O, and then the benzene ring as it is. Anhydrous AlCl3. Write this down. Let me know when you're done.
Done, sir.
Anyone still writing? No one is writing? Okay. Let's look at this question.
1 second, can you just go?
Scroll up. Okay.
Done, sir. Sir, done.
हाँ. चलिए. See what they're asking you to give the name of reagents. Okay, they're asking you to just give the names of reagent. You don't have to draw the structure, you don't have to show the conversion, you just need to give the name of reagent. So whenever they are asking to give you the name of reagent, तो ज़्यादा आप लोग advance मत बनिएगा, ठीक है? You just write the reagent that is been asked. First of all, you see what is this class of compound? क्या alkene है, alkane है, carboxylic acid है, aldehyde है, ketone है, alcohol है, haloalkane है, क्या है ये? amine है, क्या है ये? The first one, what is it? Tell me.
Aldehyde.
aldehyde है. और कोई बताइए क्या है ये?
Alcohol.
aldehyde है. फातिमा सो रही हैं क्या अभी भी आप? अभी भी नींद कंप्लीट नहीं हुई क्या आपकी? ओल. ओल मीन्स फातिमा,
Oh yeah, sorry.
this is alcohol. And you have to convert this to what? What is this class of compounds? Tell me guys. What is this? जल्दी बताइए. What is this? Look at the functional group. Last में जो होता है. Al is for. ओहो इतना टाइम. जल्दी जल्दी जल्दी.
Aldehyde.
Aldehyde. फातिमा अभी आपने नहीं कहा, अभी तो aldehyde था. अभी बताते आप. So tell me what I am going to use if they are asking you to convert alcohol to aldehyde. What are we going to use? What are we going to use? एक रिएजेंट है जो आप लोगों को याद रखना चाहिए. ये तो पिछले क्लास यानी अल्कोहल चैप्टर का भी सवाल है ना. ये तो सिर्फ इस चैप्टर का तो सवाल नहीं है. जो लोग बोल रहे सर हम फ्राइडे को नहीं आए थे, if you are thinking that, then tell me this is from alcohol also, ना? You have done this. What are you going to use if you have? Very good. PCC. Second, What class of compound is this? Tell me, guys. What class of compound is that?
Alcohol.
Again, alcohol. And we have to convert it to what class of compound is this?
Ketone.
Ketone. क्या यूज करेंगे यहाँ पे? क्या यूज करेंगे यहाँ पे? What are we going to use? What happened? बाकी लोग को नहीं आ रहा है. अहमद, रिहान, रजान. What about you guys? आप लोग आंसर ही नहीं कर रहे. Third. What class of compound is this? Toluene. Toluene क्या होता है? Raise your hand if you know what is toluene. Raise your hand if you know what is toluene. Samhiya knows what is toluene. No one. और किसी को नहीं पता toluene क्या होता है? Oh my god. और किसी को नहीं पता. Benzene ring with a CH3 group. This is toluene. Okay. Toluene से क्या बनाना है? What do I have to make from toluene? I have to make benzaldehyde. बताइए. You have alkyl benzene. देखिए हम फ्लोरो को नहीं ले रहे बिकॉज फ्लोरो इज सेम इन बोथ द केसेस. दैट मींस नथिंग इज हैपनिंग विद द फ्लोरो. So all the reactivity is due to this alkyl benzene, which is getting converted to aldehyde. Tell me the reagent. Tell me the reagent, guys.
CrO2Cl2.
हाँ ठीक है. CrO2Cl2 फर्स्ट स्टेप में. सेकेंड स्टेप में पानी मत देना भूलिएगा. ओके. यू विल आल्सो गिव वाटर. H3O plus या वाटर. Anything. Fourth one. What class of compound is this? What class of compound is this?
Nitrile.
नाइट्राइल. बताइए. नाइट्राइल से आज ही कराया है ना? नहीं आज कराया है? नहीं लास्ट क्लास में कराया था. आज भी कराया है. नाइट्राइल से व्हाट क्लास ऑफ कंपाउंड इज दिस?
Aldehyde.
एल्डिहाइड. क्या यूज करेंगे बताइए. व्हाट आर वी गोइंग टू यूज? नाइट्राइल टू एल्डिहाइड. आज ही पढ़ाया है. आज ही पढ़ाया. हाँ डिबाल एच. क्या यूज करेंगे? एच भूल गए आप? डिबाल एच. ठीक है. फिफ्थ. डिबाल एच के बाद कुछ और भी लगता है ना? पानी लगता है राइट. फर्स्ट स्टेप में डिबाल एच, सेकंड स्टेप में H3O प्लस या फिर वाटर. फिफ्थ इज व्हाट? ये तो दिया ही हुआ है बिल्कुल. अल्कोहल से
Alcohol to aldehyde.
अल्कोहल टू एल्डिहाइड. क्या यूज करेंगे? क्या यूज करेंगे
PCC.
बच्चों? PCC. सिक्स्थ में व्हाट इज दिस? व्हाट क्लास ऑफ कंपाउंड इज दिस? Tell me what class of compound is this? अरे क्या हो गया? इसको दिख ही नहीं रहा है. क्या है ये?
Alkene.
वेरी गुड. वाह फातिमा बोली. कॉफी पी लिया क्या फातिमा आपने? एल्कीन.
I don't drink coffee.
यू डोंट ड्रिंक कॉफी. एल्कीन से क्या बनाना है हमें? एल्कीन से क्या? एल्डिहाइड. व्हाट आर वी गोइंग टू यूज? फ्राइडे वाले बताएं बच्चे. सारा पार्क है एक्सपेक्टिंग आंसर फ्रॉम यू. सारा परवीन एक्सपेक्टिंग आंसर फ्रॉम यू. एंड हु एल्स वर प्रेजेंट? रजान नहीं थी. रजान वाज नॉट देयर. आई थिंक सिर्फ यही दो बच्चे आए थे. बोथ दी सारा. सारा परवीन आप जब आई थी तो कोई था क्लास में? नहीं था ना कोई?
नहीं.
आप ये हाँ सिर्फ सारा आई थी. यही दोनों बेचारी बहुत शरीफ है. दोनों का नाम भी सेम है ना? सारा अल इस्लाम. उनका वो भी नाम का असर होता है ना? नाम का असर तो होता है. फिर टेल मी व्हाट आर वी गोइंग टू यूज? अब शराफत बढ़ जाएगी अगर आप लोग को जवाब पता होगा. बोथ दी सारा. सारा पार्कर एंड सारा परवीन.
O3 and ZnH2.
You have seen that meme? वो देखा है आपने? That Pakistani he died though. Zinc H2 डालेंगे, H2 नहीं डालेंगे, zinc H2.
Could you scroll up a bit?
So this is for you, Sarah. Parveen. Wow. Like that means you remembered from Friday. चलिए. देखिए हमने स्ट्रक्चर भी नहीं बनाया, ठीक है ना? तो आप लोग स्ट्रक्चर भी मत बनाइएगा. जस्ट आइडेंटिफाई द क्लास ऑफ कंपाउंड. जब वो रिएजेंट पूछते हैं, they want you to identify the class of compound because this is not conversion. Okay, when they ask you to show the following conversion and the reaction, तो फिर आप लिखिएगा. यहाँ पे उन्होंने नहीं बोला ना रिएक्शन दिखाने के लिए, है ना? नहीं बोला, सिर्फ रिएजेंट बोला है यहाँ पे. Done everyone? Yes or no?
Yes, sir.
Anyone still writing? Anyone still writing?
Done, sir.
Done. So let's do these problems. So in the first case, what do we have? We have a benzene ring. And we have acyl chloride or acid chloride and anhydrous AlCl3. Identify this reaction. कौन सा reaction है ये? Identify this reaction, guys. Speak कराया ना अभी. Benzene, acyl chloride, anhydrous AlCl3. It is a name reaction now. What is this reaction called?
Friedel-Crafts acylation.
क्या कौन सा craft? फातिमा?
Friedel-Crafts acylation.
फातिमा आपने ट्राइटल बोला क्या?
I
Yes,
said
yeah.
Itard reaction.
Itard reaction. Itard reaction. क्या यूज हो रहा है Itard reaction में? CS2 क्यों देख रहे हैं आप? CS2 तो हमने कहा था ना. CS2 क्या है? Reagent है क्या फातिमा? CS2 is reagent.
No, sir.
What is it? Tell me. What is it? क्या है ये? Solvent है. क्या है? It is a solvent. Okay. This is Friedel-Crafts alkylation. So in Friedel-Crafts acylation, and in Friedel-Crafts acylation, ये सवाल कराया हुआ है हमने किताब अपनी, it is there in your notebook. 2 carbon atoms, no sorry, 3 carbon atoms, 1 2 3 carbon atoms, and this is going to have C double bond O. ठीक है, this is the product for the first one. Second, what is this reaction, tell me? कौन सा रिएक्शन है ये? What is this reaction? Oh my god.
Method of preparation from acyl chlorides.
Acyl chlorides and है ना di alkyl cadmium. So what is the alkyl group here? It is C6H5CH2. So you'll make C6H5CH2. Then you will add C double bond O CH3. Third one is hydration of alkyne. In hydration of alkyne, CH3, carbon with a double bond O, and then CH3. Oxygen will get attached on that carbon atom which is having lesser number of hydrogen. Fourth वाला क्या है? फातिमा बताएंगी. फातिमा, फोर्थ वाला क्या है आपका फेवरेट रिएक्शन? फातिमा, what is the fourth one?
Retard reaction.
Very good, retard reaction, है ना? NO2 as it is, NO2 में कुछ नहीं हो रहा है. This will get converted to CHO. Done, guys?
1 minute, sir.
1 minute, okay.
Done, sir.
Anyone still writing? No. Write the physical properties फिर method chemical properties next class में करेंगे, ठीक है? Right, physical properties. Aldehyde and ketones are soluble in water as the oxygen of carbon can form hydrogen bonds with hydrogen of water. So water has oxygen and 2 hydrogens. Both of these hydrogens are very delta positive because it is connected to very electronegative element, oxygen. And carbonyl compound has C double bond O. This oxygen has lone pair electrons which can interact with this hydrogen. Like this. Again, very similar thing as that of ethers and alcohols also. Only this part is favorable for solubility, only this part is favorable for solubility. The R groups that we have, or if we count the number of carbon atoms, those are not favorable for the solubility because they are non-polar. So if I am going to increase the number of carbon atoms, the not favorable part is going to increase, and that is why the solubility is going to decrease. Write the next point. solubility of aldehyde and ketones decreases rapidly with increase in the length of alkyl chain. Right, next, the boiling point of aldehyde and ketones are higher than non-polar hydrocarbons. That means alkene, alkyne, benzene, these things, hydrocarbons, and weakly polar ethers. Next point. However, due to the absence of hydrogen bonds within aldehyde and ketones, their boiling point is lower than corresponding alcohol. Done, everyone? So you have been given in this question A, B, C and D, 4 structures. कॉमा इतना छोटा है यहाँ पे. ठीक है? They are asking you to arrange the following compounds in increasing order of their boiling point. First of all, you identify again the class of compounds. So what is this? The first one is what? क्या है ये? Carboxylic acid, aldehyde, ketone, alcohol. क्या है ये? A is what? Please don't write. Let me first tell me. A is what class of molecule is A?
Aldehyde.
First class, aldehyde. Second one is
Alcohol.
alcohol. Very good, Fatima. Third one is भूल गए. हाँ भूल
Ether.
गए. हाँ ether. Fourth one is alkane है ना, कुछ नहीं, ये तो alkane है, right? CH2 है ना, alkane है. Now tell me, what type of interaction is there in between aldehydes? सो एल्डिहाइड्स आर पोलर इन नेचर। अल्कोहल में क्या होता है? हाइड्रोजन बॉन्ड होता है। ईथर इज वीकली पोलर, एल्केन इज नॉन पोलर। बताइए which of them is the strongest? Tell me here, which is the strongest here, which is the strongest intermolecular force of attraction? जल्दी बताइए, which one is the strongest?
bond.
हाइड्रोजन बॉन्ड, वेरी गुड। बाकी लोग को नहीं याद क्या? हाइड्रोजन बॉन्ड is strongest. After that, what's after that? Hey Rehan, how are you? Yes Rehan,
Yes, sir, fine.
fine. आवाज ही नहीं आती है आपकी, नहीं समझ में आ रहा आपको? You're with me, right?
आ रहे हैं थोड़ा बहुत।
थोड़ा बहुत आ रहा है। What is the next one? Tell me. हाइड्रोजन के बॉन्ड के बाद कौन सा स्ट्रॉन्गेस्ट है? Yes, this is very bad, you know, very bad. पोलर।
ईथर।
ईथर नहीं होगा, पोलर होगा। पोलर दैट मींस एल्डिहाइड। आफ्टर पोलर यू विल हैव वीकली पोलर, देन यू विल हैव नॉन पोलर। भाई याद रखिए आप लोग इस तरह से, you have hydrogen bond, then you have the polar. In polar you have strongly polar molecules such as aldehyde, ketones and haloalkanes and etc. Then you have weakly polar such as ethers, and then you have non-polars. More strong, these are weak. ठीक है, write this down. 11th क्लास की चीजें हैं ये, आप लोग को अब तक तो आ जाना चाहिए। हालोअल्किल हालोरिन में भी पढ़ते हैं, अल्कोहल में भी पढ़ते हैं, अब ये तीसरी दफा पढ़ रहे हैं आप लोग सेम चीज।